Hello everyone, welcome to my channel. In this video today, I'm going to solve question 461, Hamming distance. So the question is very simple. They are going to give you two numbers, x and y, and they ask you to return the Hamming distance of these two numbers. What is Hamming distance? According to the definition, it's just simply a number of positions where the corresponding bits are different. So let's have a look at the example. We have two numbers here, input x equal to 1 and y equal to 4. The first thing that we have to do is to convert those two numbers into binary. And then the next thing we have to do is that we just have to compare each position. For example, at this position, you guys are going to see that they have one different. And also at this position, another different. So the output is going to be going to be 2, as there are two positions that are different. Next, let's go to the second example. Firstly, we have number 3 and number 1. So let's write number 3 and number 1 here. And 3 in binary is going to be 1, 1. And 1 in binary is just simply 1. So how can we compare these two? So because the second number, number 1, is missing 0 here, so we can add a 0 here. So remember this one. When you add a number 0 before any number, it's not going to add up any value to it. And now you guys can compare. So you guys can obviously see that this position has a different. So this one going to return a 1, just exactly what is the output. So the idea behind this questions is also very simple, but some of the people would come up with a very not really efficient approach. So when they are given two numbers, the first thing they gotta do is convert both of them into binary. And the next thing they gotta do is then convert them again into string. And then they just have to iterate every position, every index, to check the difference. And if yes, they will increment the count, and at the end it will return a count. But this approach may have some edge cases, and it's very annoying. It also is not very fast as well. So before coming to the optimized approach, I'm going to tell about you guys. I'm going to get you guys to understand how we can convert a number in base 10 to binary, which is also base 2. So let's get back here. So for example, we have number 5. And in order to convert this number into a binary, what we have to do is continuously divide it by 2, and then we take the remainder. So what I'm going to demonstrate to you is that 5 divided by 2 is going to be 2. 2 times 2 is going to be 4. So 5 minus 4 is going to be 1 here. So notice that we have a number 1 here. But since this number this number hasn't become 0 yet, so you guys gotta continue to do the division. So 2 divided by 2 again is gonna be 1. And 1 times 2 is equal to 2. 2 minus 2 is equal to 0. Oh, we got another 0 here. And since 1 is not equal to 0 yet, so we're going to have to do another division. So 1 divided by 2 is going to be 0. And 0 times 2 is going to be 0. And 1 minus 0 is going to be 1. So we have 3 numbers here. So we're going to take the order from bottom to up, from bottom to top. And 5 would equal to 101 in binary. Okay, so let's move to another example. That is 6. We can do this again. So 6 divided by 2 is going to be 3. 3 times 2, 6 is 0. And then we do another division because 3 is not equal to 0 yet. So this one is going to be 1. And 1 times 2 is going to be 2. This one is going to be 1. And another time. Right. So you guys going to see that we have 0, 1, 1. And because we are going to go from bottom to top, so we're going to have 6 would equal to 1, 1, 0 at the base 2. So very simple, guys. So the thing that I want you guys to notice is that whenever you guys have a 1, have a 1 like here, you guys gotta know that the number here is not even, obviously. So what you guys can do here is that when you guys compare two numbers, for example, at this position, you guys gonna know that if we take 5 divided by 2, we're gonna have 4. And the remainder would be equal to 0, equal to 1, because 5 divided by 2 is 2, sorry guys. And then you guys gotta know that the remainder is 1 because 5 is not an even number, it's an odd number. And next, if we take 2 divided by 2, you guys still get 1, but remainder is going to be 0 because 2 is an even number. So that's this logic flow. So you guys can take 5 and 6 together. So you guys can convert the binary, both of them at the same time. So 5 divided by 2, 6 divided by 2, this one will return a 2, this one will return a 3, this one will return a 0. The remainder is going to be 1. So obviously, because 5 and 6, this one is an odd number and this one is an even number, so those are going to be different, right? So we're going to get started with the next number. I can start with the next number. Oh, what happened here? This one divided by 2 again, this one divided by 2 again. So obviously this one is an even number and this one is an odd number, so you guys can have another different. So another different here. And the last one is gonna be 1 because 2 divided by 2 is 1, 2 divided by 2 is also 1, and we can start with number 1 again. So 1 and 1, 6, those are equal, so that means that this one is odd, this one is also an odd number, so this one's gonna be equal to each other. So we're gonna have 2 in for the result, right? So let's move to another bigger example. Let's say we have 1 1 1 0 1 0 1 0 something, and then we have just 1 0 0 1, and they ask you to find the Hamming distance of these two numbers. So basically what you're gonna do here is that you guys can imagine like these numbers can add up as many zero as it can to the left, because it's not going to add up any values to it. So what you're gonna do here is that you guys gonna check. So 0 and 1 here is different, so plus 1 to the count. You guys gonna have a count equal to 0 initialized at the beginning. So we guys gonna compare this one first. Compare this one first. So because they are different, you guys gonna increment the count by 1. So we have count equal to 1. Similarly, this one is also different, so we're gonna have count equal to 2. This one is not different. This one is not different, so equal. This one also as well. This one also as well. But this one, they are different, so you guys gonna need increment the count as well. So 1 is here, so we're gonna be 3, and then different here, this one gonna be 4, and then another different here, so it's gonna be 5. So basically the logic for this one is that you guys just let x and y divided by 2, and then just comparing the remainder of them, of x, and then remainder of y when they are divided by 2. In other words, you guys just gonna check like if x divided by 2 gonna be an odd number, or even number, and then just compare with the y divided by 2 if it is also an odd number or it is a even number. So that's basically just the flow for this one. Let's get to how we can code this problem. It's very simple, believe me, guys. And this is how we can code this problem out. So basically what we're going to do first is initialize a variable and assign it to 0, just the same as what we did above here. So we're going to see here is that the condition for it is x bigger than 0 or y is bigger than 0. So the condition is very, very important because many of you guys put an and here, but that's not correct, because if x is equal, if x is equal to 0, it's going to end this loop like this case. So if, let's assume that the y here is a smaller number, so if y equal to 0, it's going to stop here. Oopsie, it's going to stop here. So we cannot compare those numbers at the beginning, at the front, and that would not give you a correct result. So what we have to do is that put an OR here. Actually, you guys can put an AND here, but then you guys have to create two other loops to check if x has equal to 0 or not, or if y have equal to 0 or not. Unless you guys can just put an OR here, just more simple. And what you guys gonna do is that you guys gonna compare if x divided by 2 and y divided by 2 are equal to each other, which means that you guys can check if they are both odd number or if they are both even number or if they're different. So if they are different, you guys gotta compare, different here, you guys gotta increment it by 1. If not, you guys just increment by 0, would mean that no different to the count. And what you guys have to do next is that you guys just need to divide each number by 2 is here. And at the end, you guys just need to return the count. And this one, the time complexity for this one is also an O1. Actually, this one gonna be like an O of maximum, the log 2 of maximum of, oopsie, let me write something out here. It can be a bit fast for you guys. Let's say that this for loop, this while loop, gonna be end up while with, and again they gotta be end up when the bigger number, in this case, in any case, like if x is the bigger number, so we're gonna end with bigger number equal to 0, right? So what we have to do is that we gotta know that the number of while loop is gonna be log 2 of the bigger number. So the time complexity would be O of log 2 bigger to number, but we can actually just put it logged here. And in order to make it more clear, we can put a max here as well. So it will be max of x and y. But practically, this one gonna be an O1 because we can do at most 32 loops. When you guys have a look at here, the constraints of it is 2 to the power of 31. So there are maximum 32 loops. 32 loops that you guys, 32 iterations that you guys can do, and that will give you an O1 time complexity solution. And that's it. Also, I just want to mention that the space complexity is also O1 because we are not using any additional memory. So, yep. Thank you guys for watching to the end. Have a nice day.